Now you'll learn about different types of surface boundaries. You'll understand the difference between destructive and non-destructive boundaries. You'll apply boundaries to your surface, share the surface using data shortcuts, and reference the surface into a new drawing. Finally, you will learn about data clip boundaries and how to use them. From the Iowa City 02_10 project Design Models folder, open the 02_10 Surface Boundaries Start drawing. We're now going to add some boundaries to our existing ground surface. You'll almost always want to add an outer boundary to your surfaces. Outer boundaries define the outer extents of the surface. In Prospector, select the existing ground surface from the Surfaces collection, right-click on it and select Rebuild Automatic. This is a toggle option, and when it's on, the surface will update automatically when any changes are detected to its definition. Expand the surface definition in Prospector, right-click on Boundaries and choose Add. Set the name to Outer. Make sure the type is set to Outer. We'll explore other options later. A boundary can either be destructive or non-destructive. A destructive boundary will destroy or delete any triangle side that's outside the boundary or is crossed by the boundary. The result is that only whole triangles inside the boundary are preserved. A non-destructive boundary will trim any crossing triangles to the boundary line and delete any whole triangles outside the boundary. In this example, we are using a non-destructive boundary, and the mid-ordinate distance is set to 10 feet. When I apply this boundary, the surface edge is now tessellated. Clearly, triangle sides cannot be curved, so there'll always be straight edges on your surface boundary. The tessellation is controlled by the mid-ordinate distance. If the mid-ordinate distance is small, then additional triangles will be created to ensure the setting is honoured. For our boundary, select non-destructive break line and leave the mid-ordinate distance set to 1 foot. Click OK, and in the drawing, pick the white polyline as shown for the boundary. The polyline remains linked to the surface. If you delete it, then you're deleting the surface boundary, and the surface will revert back to its original size. Use grips to edit the boundary. When you change the polyline, the surface rebuilds automatically and resizes to the bounding entity. In this area here, we have a polyline that represents a building outline. We don't want to display contours inside our building. In Prospector, under the existing ground, there's an item labelled Masks. Masks are not boundaries. They can be likened to a wipeout in AutoCAD. Unlike a boundary, triangles inside a mask are not deleted from the surface, they're just not displayed. Right-click on Masks and select Create Mask. Select the building polyline in the drawing and press Enter. In the Create Mask dialog, set the mask type to Inside and then click OK. Contours inside the mask are now hidden, but the surface is still there inside the building, and if I were to perform a volume calculation, it will still include triangles inside the mask. Now let's create some boundaries for this lake and island. In Prospector, right-click on Boundaries and choose Add. Name this boundary Lake. Set the type to Hide. We don't want contours inside the lake. Make sure that non-destructive break line is selected. Accept the default mid-ordinate distance and click OK. Pick the outer lake polyline, and the surface is now trimmed to our lake. Add another boundary and name it Island. This time set the type to Show. Again, it will be non-destructive and the mid-ordinate distance is 1 foot. Click OK and pick the island polyline. The surface is regenerated inside the island. You can nest, hide and show boundaries as many times as you want. If I review the surface in the object viewer, you can see the surface still exists inside the mask, but has been deleted inside the lake. Delete the lake and island polylines in the drawing and the surface will rebuild. Now we're going to create a data shortcut for the existing ground surface in our data shortcut project. First we'll save the drawing. Using the application button, select Save As and then save the drawing to the 04 Design Models folder and name the drawing EG Surface. Now in Prospector, right-click on Data Shortcuts and choose Set Working Folder. In the dialog, select Civil 3D Projects as the working folder. This is the folder that our projects are stored in. Click Select Folder. Right-click on Data Shortcuts again and choose Set Data Shortcut Project Folder. Select the Iowa City 0210 project and click OK. Right-click on Data Shortcuts again and choose Create Data Shortcuts. In the Create Data Shortcuts dialog, select Existing Ground and then click OK. Now save the drawing. We're now going to create a new design model for our road design and we'll bring in the existing ground surface so that we can base our design on it. Create a new drawing. Use Save As and save your new drawing in the 04 Design Models folder in the project and name it Road Design. In Prospector, ensure the data shortcuts are expanded. Expand the Surfaces collection under Data Shortcuts. Select the existing ground surface, right-click and choose Create Reference. In the Create Surface Reference dialog, set the style to Contours 1 foot and 5 foot background and click OK. In the drawing, use Zoom Extents to see the referenced surface. Now save the drawing. Switch back to the EG surface drawing. Select the boundary polyline and drag it out using the grips as shown. Save the drawing. Switch back to the road design drawing. You should see a balloon notification informing you that the data shortcut definitions may have changed. Click on Synchronize in the notification. Close the event viewer if it's displayed. This might be called up and is displaying warnings about break lines in the surface which we can ignore. The surface will rebuild and display the latest version. Finally, I'm going to show you a different type of surface boundary which you can use when importing very large surfaces. In this example, I have the surface that was generated from a DEM file. I can add an outer boundary to the surface and reduce its size in the model. I'll save the drawing so that I can compare it later. I've deleted the outer boundary and I'm also going to delete the DEM file from the surface. Now I'm going to add a new boundary to my empty surface. This time I'm going to set it to a data clip boundary. This type of boundary needs to be created before populating the surface, as it will be applied when data is added. Now I'll add the DEM file again and save the drawing with a different name. When I compare the sizes of the drawing files, you can see that the model with the data clip boundary is significantly smaller than the model with the outer boundary. This is because the data clip acts when data is imported and will ignore any information that's outside the boundary. The advantage is clear: no data in the drawing that we don't need, and a smaller model file that will improve performance. You've now finalized your existing ground surface by adding a boundary and sharing it in the Data Shortcuts project. You've created a new road design model file that references the existing ground, and you're now ready to start laying out the road design.